Hi, my name is Hsuan Peng. I'm a visualization developer in Wolfram. My talk is about automatic labeling in version 12. Thank you.
My name is Min. I'm a developer in Wolfram for the visualization. So today I'm going to talk about automated labeling in visualization. This is probably part 4. So I will mostly kind of like a review for what we have done before version 12. So I will talk about what kind of the automations we have, and I also talk about what kind of the factors the automation is considering. I'll give some examples, but the main idea is to just to show you that how labeling can be very useful just in the visualization itself. So I hope that I have seen that many presenters have used label stuff in their talk, which is great. And this is just a simple example here that you don't really need to show the code for the people to see that this is a normal distribution. You could just add a very simple label there and avoid all these code there. And it is like very frequently seen that in the literatures that people just put some graph just to try to say something. But the graph sometimes itself doesn't explain much, and people usually put a lot of text under it. And I mean, I don't know you guys, but usually when I'm scanning through papers, I would look at the visualizations and try to see that if there is something I'm interested in. And in this presentation, I'm going to use a lot of flip view. So I don't know if you are familiar with that. It's just instead of manipulate, which is doing things on the fly. I'm generating a lot of pictures in advance, so I don't run into the risk here. But the way I can do this is just click on the graphics, and it will cycle through what I have already generated. For example, like this. So just for the holiday. And I have like 2 other things listed here. First one is the Twitch talk. It's talking about the same object. The talk is about what's new in 12, which is the second link. So I encourage you, if you have not seen the what's new in 12, there are pretty pictures there. Right, so like come back to what I just said about the graph in the literatures. This is very common type of charts that you can see. So people put the labels on the axis and then rotate the labels 90 degrees. I think that the disadvantage of this is that the real estate on the paper is very valuable, and you are going to have like a lot of it's going to squeeze in, so say that the space is the same, but because you have to show everything in, then that vertical labels layer is going to be expensive. So I think that it's a better idea is that you can put it inside, but then it is because it's colored. If it is not colored, which is in grayscale in a lot of paper, then you run into the problem of that it's obscured. So the automation here is that we come up with some idea that we can actually set the labels that in a way that it can alternate, and then it's still compact. And I just want to show you that it is not hard-coded that it's alternating between each. So it's actually, it depends on the size of the label. It's going to do the packing automatically. So another example here is that, so there are many groups. So this is the 6 countries, their energy production chart. And then for each country, there are 5 categories. So the same thing, if you are putting the name of the countries on the axis, they certainly will work, but it may take a lot of space, and then it's not, it doesn't give you the other flexibilities if you want to add more labels. So here, this is just another example how the automations can be used. And the code here, so basically it's just like using callout wrapper on the data twice. That are those two wrappers are for this individual callout. And the other one, that's the group labels, is using chart labels. Right. So I am dividing the labels automations in two sections. The first one is the data visualization. The second one is the function visualization. In the data visualizations, what we have done for the tools in the labeling include the labeled wrapper. So it's a wrapper. So it's, you can wrap around the data point and specify the label and then some options if you like. So the first one is just the list plot. The second one is the geo list plot. I'm just taking some examples here. So there are many functions are supported. The second tool is callout. It's very similar to labeled. The only difference is that there's an extra leader line there, just for some extra clarification. The same thing, the first one is list plot, and second one is the pie chart. We have two options. We have options. One is PlotLabels. The other one is chart labels. PlotLabels is applied to the list plots. Well, anyone that doesn't end it with chart, and the chart labels is the one using the charts. So their syntax is very similar, but they are using the labels and in respect to the structure of the data. For example, that the first one is the list line plot. I have 3 data sets. So the syntax would be just plot labels go to label 1, 2, 3. And so it's, and for the bar chart, it's going to be the previous one, the one we saw about the energy production, that has 2 dimensions. The first one is the group, and the second one is the categories of the energy. So that kind of thing is translated to the chart label structure. So this is all well documented. I'll just kind of like recap the functionality. For the data visualizations, they also have another option called the labeling function. It is a very powerful option because we just provide everything to you, and you can do whatever you want. So it includes the values of each element, and it tells you the index of which current which item we are currently at. And the third one is labels, coming from all the wrappers and previous saved options. So you can use them to generate your customized labels. Here, I'm not using something fancy. I'm just giving an example for using labeling function. So the third one is a bubble chart. And I want to mention that why do we have this problem? It's so weird. It's not just those options. We have like geo labels, event labels, and contour labels. They are already existed, from various of time, since various of time, and they are kind of spatial labels for each spatial visualization. And we have a lot of visualization functions, so each of them might have a little bit, a difference from each other. And these are all supported functions currently we have for the previous set options and wrapper. So it's quite a lot. We started from this plot, and we gradually extended it to other functions. It's still not comprehensive though, so we are working on that. Now we're talking about labels in the function visualization. So it's a very similar idea. We also have labeled, but since it is not data points, so the labeled here is actually wrapping around the function itself. And you say a label, If you don't specify any position, it's going to put on the end of the curves. But if you do specify a location, it sounds like it's not so different from just using text. But the thing is that when you are using text, you have to specify precise coordinates that you want to put the label. Here it is not. You just need to specify, say the first one is a plot. You just specify the X location, and it will automatically figure out the Y location and kind of like move the labels so that it doesn't cross over the curve. So that's the automation we are talking about. And that is relatively easy until we hit the parametric plot, which is much more complicated because it's just difficult to figure out that, where the curve is going. But in the end, we still find it a way to make it work. I'm sure that you can find some cases it's going to run into the curve just because that it is sometimes the curve can like come back and make a loop and make a knot. So that is difficult. But so that is why we have the callout, which allows you to have a leader line to pinpoint to the features you want to label on the curve. The second example here is a region plot. So that is something new added. And the third one is plot 3D. So you can see that you can add some labels there and then just point out some features. We also have plot labels. So very similar to the previous case, this is for each each function. So the first example is a plot, and I think you can see there, yes. So these two labels, if there's no any algorithm running, it will run into each other because they are very close. So the automation there is just trying to find and optimize the position so they don't run into each other. The second case is a parametric plot. The automation is that how do you find a place that point to the curve? Well, this is an easy case because none of the curves are overlapping. But when they are overlapping, you don't want to find a position that is too ambiguous. So that is kind of whole algorithm is dealing with. And currently, the supported functions are here. The same, we are trying to expand it to other functions. It will be gradually. And the functions that we have worked on for the function visualization and data visualizations, they are kind of the core functions we have. A lot of the newer functions are built upon them. So we are expecting to do more and in an easier way. Right. So I want to point out that there are a few functions that are spatial. The first one is the DiscretePlot and DiscretePlot 3D. So although they are function visualizations, but they do not generate curve, they generate points because it's DiscretePlot. So the behavior is slightly different. So I just want to point out. So for example, that if it is a plot, this prime t is going to be, it's going to generate a label in the end of the plot. But instead, because the variable is presented here, it's going to generate point labels. So for example, if I use hold form on the label, so it doesn't generate the points like that. I just want to point out this is something spatial. And another thing spatial is feature space plot and feature space plot 3D. I would also use this example to introduce that the two options that we also implemented for version 12, which I'm going to just showing. It will be shown in a second. I'm going to use the data from the example data about Titanic survivors or the information. So we can look at the information of the first class person, and this is the age and the gender, and survived or died. So the data points is about 1,300, the length of it. So we can use the machine learning stuff, the dimension reduce, to reduce dimensions into two. The results of it doesn't have any meaningful units. It's just like x, y values. And then we can visualize this using this plot. And you can see that the labeling function is just printing out the data. And you can see that, this plot, the dimension reduce successfully kind of categorize them in a way. And the label here is just, the purpose of label here, the automation, is so that they are not running into the points and trying to remove the labels that running into each other. Right, so if I set the label visibility, which is an option in the callout, we can see that this is before the labels get removed. They still run through the algorithm, so you can see that most of the labels are not running into the points, but they can run into each other. And that is not desired still because the information is blocked. And the other thing that you can see is that we actually added some screen behind the labels. So when they are stacked into each other, they are not just completely unreadable. So that is the option that a lot of people are asking, that what if I'm fine with that they are overlapping, I just want to show them all. That is the option. And we can just use feature space plot on the data itself, and to see that how feature space plot is doing its magic to categorize the data. And I think it's a pretty neat graph. And for all the ones, well, mostly, that have the complete information, they somehow get transformed into some continuous line, I don't know. But for the informations that the tooltip should show up, so for the informations that is not completed, they kind of get clustered there. I have no idea why it is doing that, but I just want to point it out. The other option is called labeling size. This option is especially useful if your label is not text. For example, it can be images. So I thought that it would be fun. So I get some zombie images, and I can plot it with this plot. And the tooltip itself is a nice big image according to the size of your input. But you can see that the labeled image actually is shrunk. And the same thing, the algorithm is trying to avoid running into other points and trying to avoid running into each other. But you can still see that these two cases are running into each other. The reason is that we saw that as long as it is overlapping just a little bit, we can still see the context. So we don't need to be so aggressive on removing everything. So that is the reason. But you can see that the point over here, that is just, there's no way it can be placed in a way that it doesn't run into other images completely, or running into other points. So that was removed and put into the tooltip. So I saw that I could get another set of images, which is called the Asian zombie, I don't know, and then see that how feature space plot categorize them. And apparently it's kind of like degree of decomposition. Right, so the same thing here. So the labeling size is on top level, the first tier option in the visualization function. Right, so here is a bunch of labeling automation. I want to show you this. So this is the flip view. So while I'm adding more points, you can see the label moved because it was going to hit the point. So you can see the label, automatic labeling algorithm working there. Another factor that we considered is the density of the points. So this is just a few points, so everyone is labeled. But when there are more points, you can see labels are removed. So this is the density of the points. Another one is the image size. So the image size, the aspect ratio, and plot range, it's all going to affect the real estate of the plot. And that is the main thing that's deciding the algorithm. So you can just see that when the image size is increased, you see more labels. And for the list point plus 3D, we have the viewpoint taken into considerations. So even the 3D point, if you look carefully, none of the labels is blocking the points. Okay. Other automations, for the real plot, it's adding some extra informations about the real part or imaginary part on the labels. And you only need to specify expressions, and it will pick up the function itself. The label location for the curve, I did not do anything special to move this label. It will find the curve itself and move it along, so it doesn't run into the curve, and it doesn't go out of the plot range. So all this is, it's just called out, and the label, and this is just the location of the leader. So I did not specify where my label should be in the detail. And this is just another example how the optimization problem solving is used in figuring out the label here. The same thing for the pie chart. There are so many cases that the user is asking that how do I avoid the label being collided when the pies are very small. So here is the solution we have for you. Right. There are a lot of other spatial plots that we have to craft for the automation. One is the parametric plot, which I mentioned. How to find the positions so they are not too crowded. And the region plot, the color is completely different. The one that if you put the label outside of the region, then it will have a leader. If you put the label inside of the region, then it doesn't have the leader. So that's a Q. So the 3D plots and parametric plots 3D and the contour plots, which you can use the labeling to label the poles and zeros. Right. I have, so I'm running out of time, but this is an example from the What's New in 12 on the website. It is using the labeling stuff and some region stuff to label the Venn diagram. I thought it's pretty neat. And I don't know if this one is pretty well known, but I don't know, have you ever thought about how to do the Venn diagram for four parts? So the code is not very long, so if you have some time interested, so please read through. So that concludes my talk. Thank you.